Continuing on our 6.4 lesson on completing the square, we've talked a little about the square root property up until now, but now we're going to go to exactly what is completing the square. Before we can do that, we need to define what a perfect square is. Now, perfect square is any time that we can write our trinomial, x squared plus bx plus c, in such a way that we can rewrite it to x plus m squared. So if we can factor this piece over here into this, then we call them a perfect square. And anytime that we are looking to write a polynomial as a perfect square, it's always best to use the actual binomial squared. This sounds a little confusing. I'm going to show you a couple examples of how this works. So if we have the expression x squared plus 2x plus 1, we can factor that down into x plus 1 squared. And if you don't believe me, we can do x plus 1 times x plus 1, because this is x plus 1 squared. If we FOIL it out, we have x squared plus 1x plus 1x plus 1. Combine these like terms, and we have x squared plus 2x plus 1. So that is the same as what we have here. So we can rewrite these in these forms, so we would say that that is a perfect square. Now if we wanted to try another one, say x plus 2 squared, so we know that this is a perfect square because we are given in the binomial squared form, and we want to see, kind of go the other direction, see what it would look like as a trinomial. We do the same thing. We say x plus 2 times x plus 2. We FOIL it out. X times x is x squared, plus x times 2 is 2x, plus 2x. 2 times 2 is 4. Gives a little more room to work here. Combine these like terms. We have x squared plus 4x plus 4. So that's the perfect square trinomial. So we call both of them perfect squares. One is a trinomial, one is a binomial. Let's do one last one. If we wanted to see what x plus 3 squared was. Well, again, we just set it up so that we can FOIL it. X plus 3 and x plus 3. X and x is x squared. 3x plus 3x. 3 times 3 is 9. Combine these like terms. We have x squared plus, oops, this is going to be a 6x plus 9. So that's our perfect square trinomial. Perfect square is a trinomial, perfect square is a binomial squared. So these two are matched together. Now, one cool thing to notice here is that anytime that we have our perfect square trinomial or binomial, if we want to find out how they are linked together, if we look at this first one, we have a 2x. Notice how 2 that we have there, the coefficient in front of x, is twice the amount of our 1. So we would say 2 divided by 2 equals our 1. Similarly over here, we have 2 and 4. 4 divided by 2 equals 2, which is what we found over here. Look down at this last one here. 6 divided by 2 is 3, and that's this piece here. So our middle piece, that b value, is always going to be twice the amount of this value in our binomial. Okay? Another cool thing to look at then would be that our third value that we're looking at in our trinomial, in this case our 1, our 4, and our 9, well, 1 is the same as saying this 1 squared. So 1 squared is 1. Over here we have a 2. 2 squared is 4. Same thing as we got here. Over here we have a 3. 3 squared is 9, which is what we have over here. So this piece in the binomial times 2 gives us the 6, and squared gives us the 9. So if we want to go the opposite way, we'd say square root of 9 equals 3. And that's how we'd find this piece here. So it's nice to know how those things are linked. Now that we know what a perfect square is, either a perfect square trinomial or a perfect square binomial, we want to look at how we can make different things into perfect squares. So if we were asked to take x squared plus 10x plus c, and we want to find a value that makes it a perfect square, so we have x squared plus 10x plus something, that's going to give us a perfect square. So it's going to be x plus something squared. Well, remember we said that this value, our 10, divided by 2, which equals 5, this value is what we have right here. So we know that this is going to be 5. And we also know that that value, so again our 5, if we take that and square it, it's going to give us 25. That's this value. So we'd say that it is 25. So in this case, we found that our C is 25. So if we want to solve an equation by completing the square, this is where completing the square is kind of fully tied in. We're actually solving different equations, different quadratics, by completing the square. So what we want to notice in this, we have x squared plus 6x minus 2 equals 0. Well, in this case, we don't have a perfect square trinomial already given to us. This one is not a perfect square. So we need to make it into a perfect square. To do so, we look at just the first part, this x squared plus 6x. And we want to make that a perfect square. So remember, that's going to be plus something to give us a perfect square. So x plus something squared. Again, remember, this value here, 6 divided by 2 equals 3. This is this value here. So we know it's going to be 3. Once we know that value, we can take this value, square it. So 3 squared equals 9. 9 is going to be this value. So to make this a perfect square, we had to add 9. So over here, we're going to go back to the numbers we were given, plus 6x. To make it a perfect square, we added 9. To make sure that we do the same thing and kind of balance each other out, so we're not actually changing the entire equation, we have to subtract 9 as well. So we added 9 and we subtracted 9, so we didn't actually change the equation. Then we still have that negative 2, or should I say minus 2 at the end, and it equals 0. Now this part here is our perfect square trinomial. We can rewrite this, put our parentheses around it here, and say that it's x plus 3 squared, because this piece was the same as this piece over here. We still have our minus 9, minus 2, and equals 0. Now from here, we just combine our like terms, so we are left with x plus 3 squared minus 11 equals 0. Let's roll this down. We still coin in our form the x plus n squared equals m. We need to add 11 to both sides. That gives us x plus 3 squared equals 11. Now we are in the x plus n squared equals m form. And from here we can say, we'll move back over here, x equals square root of this one, so square root of 11, minus our n term, so minus 3. Now square root of 11, we can't necessarily reduce that anymore. So we can just say that it's plus or minus square root of 11. So we can either leave it this way, or you could say x equals negative 3 plus or minus the square root of 11. And this would be our final answer. Now in this case, to check it, you would have to plug in this whole piece, the negative 3 plus or minus square root of 11, back in for x. Or should I say up into this piece. This was our original equation. It would come out the same on this one. This is just more numbers to work with. But you'd have to plug it back into our original equation, one time using the positive square root of 11, one time using the negative square root of 11. So sometimes you will see our solutions coming out as x equals negative 3 plus root 11, or x equals negative 3 minus square root of 11. That's okay too. They're both valid ways to say the same thing. It's negative 3 and the positive or the negative square root of 11.